Right now in the Philippines, a volcano is doing something it has not done in 26 years, and scientists watching it around the clock say it is still not slowing down. Mayon, the most famous and most active volcano in the entire country, has now been erupting continuously for 192 straight days. And in the past 2 weeks, its sulfur dioxide emissions have shattered records that have stood since the year 2000. On July 10th, gas readings hit the highest level measured at this mountain in 16 years. The very next day, that number nearly doubled again, becoming the highest emission recorded at Mayon in 26 years. And on July 15th, the volcano responded with its largest explosive bursts of this entire eruption. Today, we are going to break down exactly what scientists have found, why a sudden spike in volcanic gas is such a serious warning sign, and what nearly 300,000 people living in its shadow are actually facing right now. No exaggeration, no doomsday guessing, just the monitoring data, the science, and the real stakes. Drop a comment right now. Have you ever lived near an active volcano or watched one from a distance and wondered what was actually happening underground? Tell me where you were. So many of you write in from the Philippines and across Southeast Asia, and I read every single one of those comments. If you want to know the moment anything changes at Mayon, subscribe right now. It costs nothing, and a thumbs up tells the algorithm to put this in front of the people who genuinely need to see it. Let us get into it. Mayon rises in a nearly perfect cone above the Albay Gulf in the Philippines, and it has one of the longest documented eruption histories of any volcano in the country, with records stretching back to the year 1616. Its eruptions have ranged from relatively mild strombolian explosions all the way up to violent basaltic Plinian events. And its most devastating eruption, in 1814, killed more than 1,200 people and destroyed entire towns. This current eruptive episode began on January 6th of this year, when lava first began flowing from the summit crater, and pyroclastic density currents, fast-moving avalanches of superheated gas and rock, swept down the southeastern flank for the first time in this cycle. For most of the months since, Mayon settled into a pattern that volcanologists at the Philippine Institute of Volcanology and Seismology, known as PHIVOLCS, described as sustained but manageable. Lava effusing steadily down three main channels, the Basud Gully on the east flank, the Bonga Gully on the southeast flank, and the Miisi Gully to the south, with sulfur dioxide emissions averaging around 2,300 tons per day since the eruption began. That number is not small, but it was consistent. And consistency is exactly what allows scientists to recognize the moment something actually changes. That moment arrived in the second week of July. On July 10th, PHIVOLCS recorded sulfur dioxide emissions of 7,475 tons in a single day, more than 3 times the eruption's running average, and the highest daily emission measured at Mayon in 16 years. Scientists explicitly noted that rising volcanic gas can forewarn of further eruptive activity and additional hazards, especially with poor weather conditions already affecting the region. Then, less than 24 hours later, on July 11th, the number nearly doubled again, reaching 13,128 tons in a single day, the highest sulfur dioxide flux recorded at this volcano in 26 years, and only slightly below the levels measured during Mayon's genuinely explosive eruption back in the year 2000. To understand why this number matters so much, you have to understand what sulfur dioxide actually represents underground. Magma carries dissolved gas the same way a sealed bottle of soda carries dissolved carbon dioxide. And as magma rises closer to the surface, pressure drops, and that gas begins to separate out and escape. A steady, modest gas emission usually means magma is moving up slowly and predictably, venting pressure about as fast as it builds. A sudden, dramatic spike, doubling within 24 hours, tells scientists that a fresh batch of gas-rich magma is pushed rapidly into the shallow plumbing system directly beneath the crater. Magma that has not had time to lose its gas, gradually the way older material sitting in the conduit already has. Volcanologists sometimes describe this process as the difference between opening a bottle of soda slowly, letting the fizz escape in a controlled hiss, versus shaking that same bottle first, where the same amount of gas wants to escape all at once, and takes far more of the surrounding liquid with it when it finally does. A gradual gas release over months is the mountain venting safely. A sudden doubling in a single day is the geological equivalent of that bottle being shaken. And it is exactly the kind of signal that makes scientists start paying far closer attention to every other instrument reading coming off the volcano. That same 24-hour period recorded 97 low-frequency volcanic earthquakes, the kind of seismic signals specifically associated with gas and fluid movement through cracks in the rock, along with 304 separate rockfall events. Debris shedding off the growing lava dome and flow fronts as pressure and volume both increased beneath the surface. PHIVOLCS was direct about what this combination meant. stating plainly that the emission rate was only slightly below the levels measured during the volcano's actual explosive eruption in 2000, and that elevated sulfur dioxide could forewarn of a shift from steady lava effusion toward genuinely explosive activity capable of generating hazards across the entire mountain, not just the flanks where lava is currently flowing. 4 days later, on July 15th, Mayon delivered on that warning in a smaller but still significant way, producing its largest strombolian bursts of the entire 192-day eruption, explosions that threw incandescent volcanic material high above the crater rim, visible glowing against the night sky for kilometers around. In the 24 hours surrounding that explosive episode, PHIVOLCS recorded 187 separate volcanic earthquakes, including 43 distinct tremor episodes lasting anywhere from 5 to 45 minutes each, 398 rockfall events, and 10 separate pyroclastic density currents, sulfur dioxide continuing to average over 9,000 tons per day even after the explosive release. This is the picture that makes the phrase not slowing down accurate rather than exaggerated. Every single monitored metric, gas emissions, seismicity, rockfalls, and pyroclastic activity, has trended upward together, rather than settling back toward the eruption's earlier baseline. Mayon remains at alert level 3 on PHIVOLCS' 5-level scale, defined as intensified unrest with an increased tendency toward hazardous eruption, 1 level below an imminent hazardous eruption, and 2 levels below an eruption already fully underway. The agency maintains a strict 6-kilometer permanent danger zone around the crater and has repeatedly warned that lava flows, collapse-fed rockfalls, and pyroclastic density currents remain likely on the southern and eastern slopes, with ashfall capable of spreading further depending on prevailing winds. The human toll of a nearly 7-month eruption is already substantial, even before any larger explosive event. Disaster response agencies have recorded more than 71,000 families, close to 294,000 people, affected or classified as at risk across 159 villages surrounding the volcano, and the Philippine government has already allocated more than 300 million pesos in humanitarian assistance, including well over 150,000 food packs distributed to displaced families. Adding to the danger, a typhoon has been tracking near the province during this exact period of heightened activity, and PHIVOLCS has explicitly flagged the combination as especially hazardous, because heavy rainfall falling onto the roughly 85 million cubic meters of loose volcanic material. This eruption has already creates ideal conditions for lahars, fast-moving mudflows capable of burying entire lowland communities along the approximately 40 ravines that radiate outward from Mayon's summit. Lahars are frequently more destructive to human settlements than the eruption itself, precisely because they can travel well beyond the boundaries of any exclusion zone drawn around the crater, following river channels for kilometers into populated lowland areas long after the volcanic gas and ash have already fallen. A lahar does not need an active eruption to happen at all. Loose ash, sitting on a slope from months earlier, can be picked up and turned into a fast-moving wall of mud and boulders by nothing more than a single heavy rainstorm, which is exactly why the timing of a tropical storm system, arriving during this specific window of increased volcanic activity, has disaster planners in the region especially concerned right now, watching rainfall totals almost as closely as they watch the seismographs. So what does the science actually say happens next? PHIVOLCS has been careful and precise in its public communication, stating that the elevated gas emissions could forewarn of further eruptive activity, language that reflects genuine uncertainty rather than a confirmed prediction. Volcanologists cannot currently say with certainty whether Mayon is building toward a larger explosive episode comparable to the year 2000 eruption, or whether this represents a temporary pulse of fresh magma that will settle back into the steadier effusive pattern the mountain has followed since January. What they can say with confidence is that the monitoring network watching this volcano, seismographs, gas spectrometry teams, and continuous visual surveillance is dense enough to catch further escalation quickly, and that the pattern seen so far, rising gas followed by increased seismicity followed by explosive activity, is exactly the sequence volcanologists are trained to treat seriously rather than dismiss as background noise. If you live anywhere near Mayon or travel to the Albay region, here is what is actually worth understanding right now. Respect the 6-kilometer permanent danger zone completely, since it exists specifically because of the volcano's well-documented history of sudden pyroclastic density currents that can move far faster than anyone can outrun on foot. If you live along any of the ravines draining the volcano's slopes, take lahar warnings during this typhoon season as seriously as the eruption itself, since rain on fresh ash has historically been one of the deadliest secondary hazards this specific mountain produces. Keep a dust mask or respirator on hand if you are anywhere in the wider ashfall zone, since volcanic ash is composed of fine glass and rock fragments that can cause serious respiratory harm well beyond the immediate danger zone. And if you are one of the families already displaced by this eruption, Know that emergency assistance channels remain active and that disaster response agencies are continuing to track and support affected communities as this event develops. Final thought, Mayon has spent 192 days proving that a volcano can sustain an eruption far longer than most people expect, and the last 2 weeks have proven something else entirely, that even a familiar, monitored, seemingly steady eruption can shift its character with startling speed once fresh magma finds a path into the shallow plumbing system beneath the crater. Breaking a 26-year record for sulfur dioxide emissions is not a subtle signal. It is one of the clearest indications volcanology has for genuine ongoing change beneath the surface, and the fact that Mayon followed that record with its largest explosive burst of the entire eruption tells scientists this mountain is still actively evolving, not settling down. We will keep tracking every PHIVOLCS bulletin, every gas reading, and every alert level change as this story develops. Subscribe so you do not miss it, and leave that comment below. Have you ever watched a volcano from a safe distance and felt that mix of awe and unease knowing what was happening underground? Because for the communities living in Mayon's shadow right now, this is not a headline, it is daily life. Let us get this one to 5,000 likes. See you in the next one.